What is variability? In general terms, it refers to how spread out a group of scores is. You will often hear the terms variability, spread, and dispersion used interchangeably. They all refer to how spread out a distribution is. For example, let's look at the two distributions of classroom test scores shown here. Although they both have means of 7, it is obvious that the distributions are quite different. Specifically, the scores on the left graph are less spread out than those on the right graph. Said a different way, the differences among students are much less on the left graph than on the right graph. Just as there are several measures of the center of a distribution, there are many measures of the variability of a distribution. 4 are used frequently: the range, the interquartile range, the variance, and the standard deviation. We now look at each of these 4 measures of variability in more detail. The range is the simplest measure of variability. It is the highest score minus the lowest score. Consider the 10 numbers shown here. The range is just the highest number, 99, minus the lowest number, 23, which means the range is 76. Going back to our earlier example of test scores, on the left distribution, the lowest score is 5 and the highest score is 9. Therefore, the range is 4. However, the variability on the right distribution is larger. The lowest score is 4 and the highest score is 10. This makes the range 6. A second measure of variability is the interquartile range, which is the range that contains the middle 50% of the scores. The interquartile range is calculated by subtracting the 25th percentile from the 75th percentile. If you'll recall the discussion of box plots, the 75th percentile was called the upper hinge, and the 25th percentile was called the lower hinge. Using this terminology, the interquartile range is referred to as the H spread. Let's go back to our 2 different distributions of test scores. For the left distribution, the 75th percentile is 8, and the 25th percentile is 6, making the interquartile range 2. For the right distribution, which has greater spread, the 75th percentile is 9, and the 25th percentile is 5, making the interquartile range 4. Variability can also be defined in terms of how close the scores in the distribution are to the middle of the distribution. Using the mean as the measure of the middle of the distribution, the variance is defined as the average squared difference of the scores from the mean. The data from the left distribution in our earlier test score examples are shown here. You'll remember that the mean score is 7.0, and therefore the column deviation from mean contains the score minus 7. The column squared deviation is simply the deviation from mean column squared. One thing that is important to notice is that the mean deviation from the mean is 0. This will always be the case. The mean of the squared deviations is 1.5. Therefore, the variance is 1.5. The final measure of variability that we'll discuss is the standard deviation, which is simply the square root of the variance. As you may have guessed from the symbols for variance, the symbol for the population standard deviation is the small Greek letter sigma, and the symbol for an estimate computed in a sample is S. Going back to our earlier test score distribution, if you take the square root of the variance of 1.5, you get a standard deviation of 1.225. The standard deviation is especially informative when the distribution is normal. This is because the proportion of the distribution within a given number of standard deviations from the mean can be calculated or looked up in a table. For example, 68% of a normal distribution is within 1 standard deviation of the mean, and 95% of the distribution is within 2 standard deviations of the mean.
If we look at standard deviation visually, you can see it here with the normal curve, and this is a bell curve, a normal distribution, and you can tell because the mean, the median, and the mode are right here in the center, and you can see that it looks symmetric on both sides. So 68% of your data, meaning from here, this red line, to here, this red line, represents one standard deviation to the right and one standard deviation to the left of your mean. That's 68% of your data. So 34% lie here, and the other 34% lie to the left of your mean. 95% of your data lies within two standard deviations of the mean. So another one to the right and another one to the left. So in essence, about 95% of your data should always fall within about two standard deviations of the mean.